Hi everyone, welcome to this new lecture of hydraulic machine. In this lecture, we'll solve a problem on indicator diagram. In our last lecture, we have discussed the theory part and we have derived the equations for indicator diagram. So based on the theory and the equation, we'll solve this problem. So here I have taken the question of the length and diameter of suction pipe uh, of a single acting reciprocating pump. So length and diameter given for the suction pipe of a single acting reciprocating pump 5 meter and 10 centimeter respectively. The pump has a plunger diameter of 15 centimeter, stroke length of 35 centimeter. Center of the pump is 3 meter above the water surface. So atmospheric pressure head is given 10.3 meter of water. The pump is running at 35 rpm and we need to determine the pressure head due to acceleration at the beginning of the suction stroke, the maximum pressure head due to the acceleration, and the pressure head in the cylinder at the beginning and at the end of the suction stroke. So these are the points need to be calculated. So before going to the calculation, let's identify the data given. In the first step, let's write down the data given here. So in the data first line you can see the length is given, length of the suction pipe. So that will I mark it LS. So LS is given 5 meter. Then diameter is given. Diameter is DS. So DS is given 10 centimeter. So 10 centimeter we can convert into meter. That is 0.1 meter. So diameter of the suction pipe is given means we can calculate the area of the suction pipe. So AS, area of the suction pipe. So that is 5 by 4 DS square. Okay, so we can write this is 5 by 4 into 0.1 square. So let's calculate this. So this is 0.1 square into 5 divided by 4, 0.00785. So here we got the value 0.00785 meter square. Okay, next is given the plunger has a diameter of 15 centimeter. So plunger diameter, let's take it capital D, that is 15 centimeter. So this also we need to convert into meter, and this also we need to do it in we need to calculate the area also for this. Okay, so here we will calculate the area. Again the same thing, 5 by 4 d square. So we'll get the value directly. I'll calculate here. So let's make it 0.15 square multiplied by divided by 4, 0.01767. So this is 0.01767 meter square. Next, the stroke length is given. So stroke length L is given 35 centimeter. Again, this 35 centimeter will convert into meter. This is 0.35 meter. Okay, so from the stroke length we can calculate the crank radius. So crank radius is nothing but small r. So small r equal to capital L by 2. So divide 30.35 by 2. That one we can identify. This is 0.175 meter. Next is given the pump. The center of the pump is 3 meter above the water surface. That means the center of the pump from the water level is 3 meter. That means it is the suction head. So it is HS. So HS is 3 meter given, and the atmosphere pressure head is 10.3 meter. So we know that atmosphere pressure head is capital H ATM. That means the water surface level, like from the bottom to the central point of the pump, the total distance is 10.3 meter, and the pump is running at 35 rpm. So speed is given 35 rpm. So these are the data are given for this question. Now let's find out the question asked. First point, we need to calculate the pressure head due to acceleration at the beginning of the suction stroke. So first point, I'll write down the equation for the pressure head due to acceleration in the suction pipe. Okay, so that is denoted as the HAS. This is HS, this is HAS. This is suction head, and this is the suction. This is the pressure head. This is the pressure head due to acceleration in the suction pipe. That's what HAS. And the formula is for this is LS by G into capital A by small a s into omega square R, and this is cos theta. This is the formula. Now here actually the theta we need to see at the beginning of the suction stroke. So beginning of the suction stroke is theta value is 0, like the crank position. If you see before moving, like at the static condition, steady condition, our crank angle will be 0. That's why theta equal to 0. Then it will move 90 degree, 180, 270, 360. That will be in that way it will complete one revolution. So here at the starting position, the theta value is here 0 degree. So we can write this cos theta equal to, this is 1. Okay, cos theta equal to, you can write 1. So in this case we can write HAS equal to, so we'll put this remaining value L. LS equal to how much? This is 5, G 9.81. Area of this capital A is how much? 0.01767 divided by this area 0.00785 and into this omega square. Okay, omega need to be calculated. So omega equal to actually angular velocity. So omega equal to, this is 2 pi n by 60. So 2 pi n by 60 nothing but 2 into, this is 3.14 into n equal to 35 given. Okay, the speed given, and this is 60. So if you calculate, you will get some 4 to 5 point something value will get it here. Let identify and make it 0. 2 into pi into 35 is divided by 60. 3.66 radian per second. So 3.36665. So let's write down 3.665 this much radian per second. So here I'll write the same thing, like 3.665 square into r, omega square into r. So r also we have calculated, r value is 0.175. So this is 0.175. Now we need to write down the value of HS. That is our answer. So let's solve it. So this is already omega is there. So I'll make it omega square into 0.175. Okay. Then multiply 5 multiply 0.01767. Okay. And divided by bracket start 9.81 multiply 0.00785 bracket close, 2.687. So we got here the value 2.688 we can write, or 2.69 we can write here. So 2.69 meter. So this is our first answer. Okay. Now the second question is given. We need to calculate the maximum pressure head due to acceleration. That means what acceleration formula is the same formula we are going to use here, but here we need to calculate the HS maximum. So the maximum formula of this pressure head due to the acceleration is nothing but LS by G. Same formula will be there, only cos theta will be not there. Area to omega square r. So for this value also we'll get the same answer, 2.69. Okay, this is the answer for this. And the last one is asked about the pressure head in the cylinder at the beginning and at the end of the suction stroke. So two things we need to calculate here, the beginning of the stroke and end of the stroke. So we need to calculate the pressure head. So pressure head, you can write pressure head at the beginning and pressure head at the end of the suction stroke. So two things we need to calculate. At the beginning of the stroke, we need to consider the original suction head and the acceleration due to the pressure head due to the acceleration. So for this we'll write HS plus this one will write HAS. And here we need to do for the end of the suction stroke, actually this will be HS minus HAS will be there. Okay, this is the two things will be there. I'll tell you how to find out the final answer here. Now see, the pressure head in the cylinder at the beginning of the suction strokes, that will be HS plus HAS. So HS equal to how much? 3 meter given. In the question itself is given 3 meter, and HAS we have calculated just now, 2.69. So this is 5.69 meter is the pressure head at the in the cylinder in the beginning of the suction stroke. Now this pressure head in the cylinder also will be like below the atmospheric pressure. You can see this is the below the atmospheric pressure head. So this is below the H atmospheric, we can say, or atmospheric head. Now we can find out absolute pressure head in the cylinder at the beginning of the step. Okay, so let's find out the absolute pressure head at the beginning of the suction stroke. At the beginning of suction stroke. So what we will write for that? For this, we need to write down the atmospheric pressure head, minus the pressure head what we got at the beginning of the stroke. Okay, so this is, you can write how much? 5.69. That means H ATM equal to how much? That is 10.3 minus this is 5.69. So we'll get here, calculate 10.3 minus 5.69, 4.61. This is the answer, 4.61 meter. This is the first one. And for the end of the stroke, similarly, we can calculate the absolute pressure head in the cylinder at the end of the suction stroke. You can write again HS minus HS, as I told you. So this will be 3 minus 2.69. So we'll get here how much? 0.31. 0.31 will get. Okay, I hope it is correct. 0.03. Yeah. So this much will get here. Let's make it 3 minus 2.69, 0.31 meter. Correct. Now this much water level below the atmospheric pressure head. So below the atmospheric pressure head means we can write that end of the suction stroke, that is absolute pressure head, minus how much below is there? This much. So that is 0.31 meter. Okay. So we'll get finally this will be gone 9.91, I think. This minus 10.3 suppose. Yeah, 9.99. This is 9.99 meter of water level. This much of water level, and this is the absolute one. Okay, this is the value for the absolute one what we got. This is the final answer. Okay, so this is the answer for the at the end of the suction stroke, and this is at the beginning of the suction stroke. And remaining answer we have seen. So like this, we need to solve the problem here. I hope you understand this problem. Still, if you are having any doubt and query regarding this, then give a comment on that.